All right, welcome to this video is part two of the notes that we took the other day on points of concurrency. Basically, we know what the different points of concurrency are: your incenter, circumcenter, centroid, and your orthocenter. Now we're going to look at some different properties that these different points of concurrency have. Now, the one that you're not going to see on here is the orthocenter. Biggest thing that you have to know about that one is just the name. And make sure that you can construct it, because it doesn't have any special properties that we're going to talk about. And we'll talk a little bit in class about why that one doesn't really have any special properties. Okay, all right, so for this first investigation, I'm going to give you an opportunity to construct it. We are going to discuss the conjectures and what's supposed to go in the blanks in class. So make sure that you go through the investigation and have the conjectures and the blanks of these little definitions filled out. Okay, so for the first one, we're going to investigate the circumcenter. Now, on all three of these investigations that you're going to do at home, make sure that you have the notes, the triangles that you used, and the constructions that you did for the part one notes. We're going to use all of those. If you don't have those, then go ahead and reconstruct everything. All right, so in the first step, you're going to take the triangle that you constructed the circumcenter on, and I want you to measure and compare the distances from the circumcenter to each of the three vertices. Are they the same? Now compare the distances from the circumcenter to each of the three sides. Are those values the same? Okay, now I want you to use a compass, and I want you to construct a circle with the circumcenter as the center, and I want it to pass through any of the triangle vertices. What do you notice about that circle? Okay, all right, so now I want you to use your observations to answer the following conjecture and definitions. So for your circumcenter conjecture, the circumcenter of a triangle is, and it's going to be a phrase, it's not going to just be one word. And for that last blank, the circle is something around the triangle, and that's just going to be one word. Okay, that one you might not know, so we'll talk about that one in class. Okay, all right, so if you need to, pause it, finish the steps, answer the conjectures, and then when you're done, unpause it and move on to the next one. All right, so this third investigation, or the second investigation today, we're going to do the incenter. So find your triangle that you constructed the incenter on from the first notes video. And I want you to construct, remember we did a perpendicular construction through a point, not on a side. Okay, so that's what our incenter is going to be. So you're going to construct the perpendicular from the incenter to any one of the sides of the triangle. You want to mark the point of intersection between the perpendicular line and the side of the triangle. You don't need to draw the perpendicular all the way in. You can if you want, but you don't need to. You really just need to put a mark through the side where that segment would be perpendicular through that incenter. Okay. Now, on step two, I want you to do that for all three sides. So you should have three markings on the three sides where those perpendiculars are. Finally, on that step two, I want you to measure the distance from the incenter to the marked points on your triangle. What do you notice about the lengths of those sides? Okay. Then step three, I want you to use a compass to construct a circle with the incenter as the center, where you're going to put the middle point of your compass. And I want you to, and that circle should pass through the point of intersection, all 3 points of intersection that you constructed in step two. What do you notice? What do you notice about those segments compared to what's going on with the circle? Okay, and I want you to use your observations to answer the following conjecture. And there's also a definition that goes with that. Okay, so the incenter of a triangle is, again, it's not just a word, it's going to be a phrase. And a circle is, there's going to be just one word here, a circle is blank in a polygon if and only if it touches each side of the polygon at exactly one point. You might not know that definition, that's fine, we'll talk about it in class on Monday. Final investigation that you're going to do tonight or this weekend is on the centroid. So using your notes, again, use your notes in the part one video, find your centroid construction, and I want you to take that centroid that triangle, and I want you to label your triangle as C and R, and I want you to, those are for the vertices, and I want you to label the median, so that midpoint as T, O, and E. Okay, so now make sure your segments, those medians, are C, T, N, O, and R, E. Okay, and I want your centroid to be point D. Okay, now I want you to investigate whether there's anything special about the centroid. Is the centroid equidistant from the three vertices? What about from the three sides? Is the centroid the midpoint of each median? So see if you notice anything about that. After you're done with that, I want you to think about how the centroid divides a median into two segments. Okay, you've got the segment that goes from the vertex to the median, from the vertex to the centroid, and then from the centroid to the side. So those are your two parts that you're going to focus on. Okay, so I want you to take one of those medians, I want you to use your ruler, and I want you to measure those different segments. So basically, let's say you want to take segment CT. I want you to measure CD and TD and see what you notice. See if you find some sort of a ratio going on there. Then I want you to do the same thing. Measure ND and OD. See if you notice a relationship there. See if it's the same. Then measure RD and DE and see if there's a similar ratio there as well. Okay, finally I want you to finish this conjecture. This one's just going to be a one-word fill in here. So your centroid conjecture, the centroid of a triangle divide each median into two parts so that the distance from the centroid to the vertex is blank. The distance from the centroid to the midpoint of the opposite side. Again, just one word there. Okay. All right. Thanks for watching this video. There's one more conjecture, but I want to do that in class so you can kind of see what's going on with that conjecture, and we'll kind of tie everything all together in class. Thanks for watching.